And this is the last part of our chapter 2, distinguishing elements and compounds. What are elements and how are elements and compounds different? So, see here. So, an element is the simplest form of matter that has unique set of properties. Oxygen. This is the symbol for oxygen. Hydrogen, cobalt, helium. These are all elements and you cannot separate these into any further simple material. They are already the simplest, the purest form of a matter. I want to mention something here. For example, here we say cobalt. The first letter for the symbol is capital. The second letter is small. Helium. The first letter is capital, the second letter small. Some of them only has one letter for the symbol. If it has more than one letter for the element symbol, the first is capital, the second one is small. Compound is a substance that contains two or more elements, chemically combined in a fixed portion. So the important thing is chemically combined in a fixed portion. For example, water. Water is a compound. It has a fixed portion. It has 2 hydrogen, 1 oxygen. Carbon monoxide. It has 1 carbon, 1 oxygen. If it has 2 oxygen, 1 carbon, then it is going to be carbon dioxide. You know, carbon monoxide is toxic, but carbon dioxide is not. So this is how the ratio, the proportion of the elements in compound affect the property. And you can separate the elements here. You can separate the carbon, hydrogen, oxygen from these compounds by chemical changes, not physical changes. Here it says compounds can be broken into simpler substances, which are elements, by chemicals. But elements cannot, because elements are already the simplest form. So breaking down compounds, which means chemical change. Chemical change, for example, you have sugar. Sugar is a compound. If you heat it, you are applying a chemical process here. It's going to go a series of chemical changes. It's going to turn to black compound, and you will see some water at the pan, at the bottom of the pan. So that is a chemical change. So what happens here? Sugar compound takes the heat, it turns into carbon, which is the black compound, black element there, and water. And if you take water, which is H2O, if you apply electricity, you can see hydrogen and oxygen gas bubbles into water. So these are all chemical change. Heating, applying electricity, they are all chemical changes. So properties of compounds, they are quite unique from their elements. For example, sodium and chlorine, they are elemental form, sodium element, chlorine element. When they chemically combine, they make sodium chloride compound. And it is a huge change here. Let's check. Chlorine is a gas, and you can kill the bacteria in the swimming pools with chlorine. Sodium is a metal. You see this is a grayish metal, which is very active. So if you combine sodium and chloride, you make table salt. And it is not yellow or it is not metal. It is white crystals here. So it makes a different form here. So how can you distinguish substances and mixtures? You are going to check their composition. If it has a fixed proportion, fixed like H2O, it is a substance. If the proportion is very like salad, like air, like cereal, like your coffee in the morning, tea mixture, if the composition change, then we call it a mixture. This is an example. So they are going to ask that kind of questions in the regions. They are going to give you a material. This is a blue-green solid. They heat it, a colorless gas and black solid form. So two things form. When you heat, you observe a gas and it turns to black. All three materials are substances. So this starting one is substance, this gas and this black solid are substances. Is it possible to classify these substances as elements or compounds? So we know that blue-green solid should be a compound because when you heat it, you have gas and black solid. But we are not sure about this gas or this black solid. We are sure about this blue-green solid. It's a compound. It is not element because it can form new materials. But we are not sure about this gas and this black solid. Heating can cause chemical change. It says here. Compound can be broken down into simpler substance, but element cannot. So the solution here, it says that before heating there was one substance. After heating there were two substances. Blue-green solid must be a compound. Based on the information given, it isn't possible to know if the colorless gas or black solid are elements or compounds. Symbols and formulas. What do chemists use to represent elements and compounds? We use symbols because we want everyone to understand the chemical languages. We use symbols for the elements, formulas for the compounds. These are the earlier symbols, like many years ago, alchemists or Dalton, they used that kind of symbols. But now we are using two-letter symbol. For example, sodium. It's a metal. The Latin name is natrium, so we take Na. Remember, first letter capital, second letter small. Let's go back. Potassium, Latin name is kalium, K. Antimony, Latin name is stibbium, first letter S capital, B is small. So here, these are some confusing one because, for example, it is gold. We don't say Go, we say aureum in Latin. So we use AU. As practicing, you will be more familiar with the symbols. Also, you will have your periodic table with you, so you can go and check the symbols of the elements anytime you need. And the last part is chemical changes. We studied physical changes. Now, what happens to chemical changes? Substance undergoes specific chemical changes is called a chemical property. What are these changes? So if it is a physical change, the composition matter never changes if it is physical. So if it is water, melting, boiling, evaporation, it's still water, it is still H2O. But if it is a chemical change, you are going to break down hydrogen and oxygen into gas particles. For example, here, iron and sulfur. You are heating iron and sulfur. It forms iron sulfite salt here. You are going to form a salt. Iron is a metal. Sulfur is a solid element. And then when you mix them, you will have a different compound here. Chemical change is also called chemical reactions. One or more substances change into one or more new substances during chemical reaction. So, reactant is the starting point of reaction. When the substances that start the reaction is called reactant. The substances produced the reaction is called the product. For example, you take hydrogen gas. Don't worry about these numbers yet. We will study these numbers. You take hydrogen gas. You take the oxygen gas. You combine them with electricity, or this is heat. You combine them with heat. You apply them heat. And they make water. These two are called reactant. They start the reaction. This arrow shows the reaction way. So you are telling that I start with hydrogen and oxygen and I go to water as a product, right? This is called a chemical reaction. So what are the 4 clues about the chemical reactions, chemical changes? We are looking for 4 different clues. Change of energy, like heating, cooling, temperature change. Change in color. Production of a gas, if you see bubbles in the reaction. Or formation of a precipitate. Precipitate means, for example, you are mixing two liquid substances and you start seeing solid particles in it. So precipitate is a solid form that settles into liquid mixtures. So if you say, let's go through this again. Temperature change, color change, gas formation, solid, which is precipitate formation. These are the clues for the chemical change. Like color change, you see we have color change here, we have another color change here, there is also heat change, temperature change, energy change. So what happened to mass of the reactants and mass of the products in chemical reaction? This is very important. The mass of the products are equal to the mass of the reactants. So what goes in should go out. This is called law of conservation of mass. Mass should be the same from the reactants part and from the product part, which means, for example, you start with 43.43 gram of material at the beginning. Then you take this one and you put it into this one. You start forming yellow precipitate. You see this yellow little solid particles form in it. This is most probably lead and chloride. So this yellow is lead chloride form. And what happened to mass? Mass is the same. This is called law of conservation of mass. Elements and law of mass does not change during chemical reaction. This is very, very important. There will be questions in the regions about this. End of chapter 2. I finished all chapter in 3 parts. I know they are very long videos, but just please watch them, and there will be some practice work from the regions questions later. Bye everyone.